Hey guys, so today we're going to be comparing ionic and covalent compounds. They have very specific properties that each one has, and sometimes you can have a little bit of both, but in general we're going to be talking about perfect ionic compounds and perfect covalent compounds. Okay? Whenever I say the word molecular, what I mean is covalent. Alright, so first thing, forces of attraction between atoms in an ionic compound are very, very strong. However, covalent compounds, the forces between individual molecules is actually not extremely strong. Okay? This difference in strength of attraction between the basic units of a molecular and ionic compound give rise to different properties between the two types of compounds. So, now, just to clarify what that all means, what I mean here is that when you're looking at an ionic compound, you're looking at charged molecules that are all attracted to each other. They're very stable in this formation. They can obviously be broken apart, but what I'm talking about is the actual interaction between each individual atom. When I say that bonds between compounds in a covalent compounds are weak, I don't mean the actual covalent bonds. You see this, the solid line, the covalent bond? This is actually a pretty strong bond. But the bond holding this covalent compound to this one, I don't know if you guys can notice, but this is obviously water, is actually pretty weak. This is why water is usually found in a liquid state, because these guys are not completely stuck to each other. Unlike in an ionic bond where every atom is actually stuck to the other, right? So covalent compounds can be fluid and liquid, and they can have all kinds of different properties than ionic compounds just because the bonds between them are weaker. Okay, so let's move on. All right, so you guys, first thing you should know, molecular compounds have relatively weak forces between the individual molecules, which means that they have low melting points. So they'll often be found as liquids, or if they're found as solids, they can easily be melted. While ionic compounds have very strong attractive forces between them. This basically means that they have very high melting points and they're usually solids. So for example, salt. The table salt that you eat every day, that has a very high melting point and it is almost always found as a solid, right? Another cool thing, they can conduct electricity when they are in a liquid state. So, ionic compounds have very high melting points because of how strong the bonds between their atoms are, and they can conduct heat and electricity. And because of the extremely strong bonds between their atoms, they're almost always found as solids. All right, so you guys, this is going to be a very important table. You can look at this while you're working on your worksheet. And as you can see here, covalent compounds do not conduct heat and electricity. So for example, if I had like sugar or oil or something like that, a covalent compound, it would be a very poor conductor of electricity, and we're going to get a little deeper into that soon. They also have low melting points, so you can actually find them as liquids in room temperature, and most of them are insoluble in water. This means that they do not want to dissolve in water, while ionic compounds are the complete opposite of all of that. They love to interact with water, which means that they're soluble. They have high melting points, so they're usually found as solids, and they can conduct heat and electricity. All right, so the reason covalent compounds have lower melting points, a low melting point basically means I don't have to heat up this substance to an extremely high temperature for it to become liquid. So if you look at this is water. I know you guys have learned this in grades 6 and 1 and whatever. Ice turns into water very easily. Not a big deal. You guys can do this every single day. However, an ionic compound like salt is very difficult to actually melt, so it has a very high melting point. This is just because the bonds between atoms in an ionic compound are a lot stronger than the bonds holding water molecules to each other. Okay, so we can look at this table right here. You're going to find a set of ionic compounds and a set of covalent compounds. If you look over here at the melting points, you can see that there is a very clear difference between ionic compounds and covalent. So if you look at, let's say for example, hydrogen sulfide. Hydrogen sulfide is the stuff that smells like rotten eggs, and if you ever find it in a lab, you're going to find it as a liquid. And this is because hydrogen sulfide melts at negative 86 degrees Celsius. So even if you took the hydrogen sulfide as a liquid and you put it in your refrigerator, it is not going to freeze because it needs to reach negative 86 degrees Celsius to actually become solid. This is because it's a covalent compound. The bonds between the hydrogen sulfide molecules are very weak, so they do not come together to form a solid. But then, when you look up here at sodium chloride, you'll see that it has a melting point of 801 degrees Celsius. This basically means that it is extremely difficult to actually melt salt. Yes, you can dissolve it in water, but melting it would be very difficult. You can't, if I put salt in my oven, it would not melt because my oven could never reach 801 degrees Celsius. So, remember, sodium chloride and other ionic compounds have very, very strong bonds that hold their atoms together, while covalent compounds, the bonds between the molecules actually allow them to be more fluid and to fall apart and to become liquid more easily. All right. Now we're going to talk about solubility. Remember, solubility doesn't really have much to do with the strength of how strongly they're all held together. Solubility actually has a lot to do with the charges of the molecules. Now, if you guys look at a water molecule, you'll remember that we said that they were polar, meaning that they have an area that is slightly or partially negative, and another area, which is the hydrogens, which are slightly positive or partial positive charge. This creates a difference in charge throughout the entire water molecule, which allows it to interact with charged atoms. So, when I take a substance like this is a sodium chloride crystal, and I mix it into the water, all the water molecules will start coming up to the sodium chloride and try to interact with the sodiums and the chlorides. So, when a chlorine interacts with water, all of the little positive ends of the water are being attracted to this chlorine, and it separates it from all the other sodiums. This is why chlorine will dissolve away from the huge crystal and go and interact with the water instead. While sodium is a positively charged ion, so it's going to be interacting with the negative sides of the water. So if you guys see here, all of the red, the oxygens are interacting with the sodium because they have a partial negative and they are attracted to this partial positive. This is why charged molecules can be dissolved in water because the water wants to interact with them. Other compounds like covalent compounds, as you guys already know, are not charged. So, in general, they're not charged, so they don't want to interact with water. If I take a diamond and I put it into some water and I mix and mix and mix for years and years and years, it is not going to be interacting with the water because it's not charged. However, there are some cases where there are covalent compounds that have partial charges which can interact with water, but we're not going to get into all of that today. All right, and finally, electrical conductivity. Electrical conductivity means that you are able to conduct electricity. You guys already know that metals are very good conductors of heat and electricity because they allow electrons to flow freely through them. Now, ionic compounds are a little bit different. So, if you look at an ionic compound when it's in its solid state, It's found in a crystal like this. Obviously, there would be more parts to this crystal, but they're not moving, right? If I take an actual piece of salt and it's in its solid state, it cannot conduct electricity because the charged particles are not actually able to move. Remember that they hold on to their electrons. This chlorine now has an extra electron and the sodium has its own electrons. They don't want to give them back to anyone and they don't want to lose them. They're happy being charged like this. But as long as they're in their solid state, you actually can't conduct electricity. As soon as you mix them into water, they begin to dissolve and interact with the water, and they will become attracted to things of an opposite charge. So if you ever perform this experiment, this is basically showing how can electricity be conducted through water. Pure water will not conduct electricity very well, but as soon as you mix salt into the water, electricity will be able to flow more easily. This is why it's more dangerous. You are more likely to be electrocuted if you are dealing with salt water over fresh water. Okay? So, when I take this sodium chloride crystal and I mix it into the water, it interacts with the water the same way that we just looked at earlier, and it starts to become attracted to the different parts of the electrical circuit. This is called a cathode. It's negatively charged and it attracts positive particles. This is called an anode. It's positively charged and it attracts negative particles. If these guys were in a crystal, they would not be able to move. As the chlorine goes from this side of the water to this side, it carries charge with it, which means that the electrical charge can go through the water, back up through the battery, and it'll just keep going like this. If they were in a crystal form and not dissolved, they couldn't do this. Another thing, if you actually melted this instead of dissolving it in water, that would also free up the atoms and they could also be able to move and conduct electricity. Alright, so you guys, now if you haven't already watched the video that is found on Shobi, it's basically a little science experiment that shows all of this in person. You guys do have to go and watch that video. Remember, it's found on Shobi. Watch it before you start doing the worksheet. It's really good. And that's pretty much it. So you guys, now you can go here to day 4. Here's the video. Then do the worksheet. Remember, the worksheet has 2 pages today, and this is just a bonus mark. So if you really can't figure it out, that's okay, but it is worth a bonus mark, so it's always worth a try. And it's just really interesting to know. And then don't forget, you also have to do the quiz. All right, guys, good luck.